Moving to the theorem number 2, that is the Euler line theorem. I will read the statement. The circumcenter O, the centroid G, and the orthocenter H of a non-equilateral triangle are collinear. You must note it. This statement is talking about a non-equilateral triangle. These 3 points in a non-equilateral triangle are collinear, and that GH equals to OG. Also, this OG is said to be the Euler line of the triangle. So, in an equilateral triangle, all 3 points are actually the same. So, it doesn't make any sense to specify them as collinear. So, to prove it, I have a triangle ABC with O being the circumcenter and H being the orthocenter. I have dropped a perpendicular OA dash on BC. Now this is perpendicular to BC, and also it is passing through the circumcenter O, so it must be the perpendicular bisector. That is, A dash is the midpoint of BC. So OA dash perpendicular to BC. Also AE, which is the altitude, is also perpendicular to BC, and this implies OA dash parallel to A. This OA dash is parallel to A. We can also write it as OA dash parallel to AH. Now we will try to prove that these two triangles A dash OG dash and G dash AH are similar. So in triangle A dash OG dash and triangle AH G dash, angle G dash AO equals angle G dash AH. Angle G dash A dash O equals angle G dash AH. A dash OG dash and triangle AHG dash. Angle G dash A dash O equals angle G dash AH by alternate interior angles, since OA dash is parallel to AH, and angle A dash OG dash, angle A dash OG dash equals angle AHG dash. Same, alternate interior angles, and angle A dash G dash O equals angle A G dash H, since these two are vertically opposite angles. Hence these two triangles are similar. That is, triangle A dash O G dash similar to triangle AH G dash, implies A dash O by AH equals OG dash by HG dash equals A dash G dash by AG dash. And using the previous theorem, part 2 of theorem number 1, AH equals 2A dash, 2 into OA dash, that is this value AH by, since AH equals 2 OA dash, theorem 1 part 2. So this AH by AO dash becomes 1 by 2. So we have 1 by 2 equals OG dash by HG dash equals A dash G dash by AG dash. From here, A dash G dash into 2 AG dash. So basically what we are getting, that this point G dash divides this AA dash, which is actually the median, since A dash is the midpoint of BC and this AA dash is connecting the opposite vertex to the midpoint of the opposite side. So this AA dash must be the median, and this G dash point is dividing this median in the ratio of 2:1, as we can see, because 2 times A dash G dash equals AG dash. So this G dash must be the centroid, because only centroid divides the median in the ratio of 2:1. Hence, which implies G dash is the centroid. And if G dash is the centroid, then clearly O, G dash and H are collinear. Now OG dash by HG dash is also equal to 1 by 2. OG dash by HG dash equals 1 by 2, which implies HG dash equals 2 into OG dash. Now this G dash is actually the centroid, so if we denote it as G, then HG equals 2 OG, which is the statement of this theorem. So we have proved both the part of this theorem. That if H is the orthocenter of triangle ABC and H produced meets BC at D and the circumcircle of triangle ABC at P, then HD equals DP. Basically, D is the midpoint of HP. So we have a triangle ABC, H is the orthocenter, so BHE is the altitude and AHD is also the altitude. This ASD or AD, when produced, meets the circumcircle at P. Now we know that the same arc subtends equal angles at all the points of the circle. So what we have, this arc CP, we have this arc CP, and the angle subtended by this arc at point B, that is angle PBC, and the angle subtended by this arc CP at point A, that is angle PAC, are equal. So what we have, angle PBC equals angle PAC, angle subtended by same arc. Now consider this triangle BEC. This is 90, this is angle C. So this angle must be 90 minus C. That is angle EBC equals 90 minus C. So that the sum of these three angles becomes 180. Similarly, if you consider this triangle ADC, this is 90, this is C, so this angle must be 90 minus C. So angle DAC equals 90 minus C. Simply we can say angle EBC equals angle DAC. DAC is actually angle PAC. Now if you consider it as 1 and this as 2, then clearly angle EBC from 1 and 2, angle EBC equals angle PBC from 1 and 2. Now consider these two triangles HBD, this, and PBD, this. These two triangles, this angle is 90. We just proved that angle EBC equals angle PBC. EBC means this angle is equal to angle PBC means this angle. So these two angles are equal. This is 90. This is 90. These two angles are equal, and the included side between these two angles, BD, is the common side. So we can just prove that these two triangles are congruent via ASA congruence. So let me write the needful in triangle HBD and triangle PBD. We have angle HBD equals angle PBD. Angle HBD equals angle PBD. If you say it as 3, so you can write here from 3. So angle HBD equals angle PBD, BD equals PD, common side, and angle HDB equals angle BDB equals 90 degree. So these two triangles, therefore triangle HBD is congruent to triangle PBD via ASA congruence. Now since these two triangles are congruent, therefore HD implies HD equals PD. HD equals PD, therefore D is the midpoint of HP, and hence we have our theorem proved.